morning to everyone who are joining us today. Welcome to all school students, teachers, parents from all around Malaysia. Not forgetting all UMS students and all UMS staff present in this session today. Thank you, and we meet again for today's session of STEM Speaker Series. For those who joined us for the first time, this STEM Speaker Series is a co-joint effort with the Faculty of Food, Science and Nutrition, University Malaysia Sabah, aimed to deliver unique and interesting STEM topics designed by subject matter experts to increase the interest of school students, teachers, and community alike to venture in the fields of STEM. For any questions from audience today, please feel free to drop your questions on the chat box at the right side of this YouTube live session. Please be informed that for today's session, e-certificate will be given to school students and UMS students, but must fill in the form through a QR code which will be shared at the end of the program today. So please stay tuned with us. Allow me to introduce our speaker and the topic for today. Today, our topic will be ocean and climate, which will be discussed by a distinguished academician from Borneo Marine Research Institute, Dr. Madihah Jafar Sidik. Dr. Madihah is a senior lecturer and enthusiast researcher at the Borneo Research Institute, University Malaysia Sabah. She is interested in the studies of oceans and climate. She has also received a PhD from University of Prefectural Bangor, University of Wales, United Kingdom. She is also a homegrown graduate who received Bachelor of Science and Masters in Science from UMS. So without further ado, please welcome Dr. Madihah with a topic Ocean and Climate. Doctor, please be invited.
Thank you very much, Katie, for inviting me for this special session. Assalamualaikum and a very good morning to everyone. I'm very happy to share some of the knowledge from my research. Knowledge about ocean and climate. Okay, before we start our talk today, I would like to ask you, can you look at outside your window? What is the weather today? Is it raining, sunny day, overcast? You might be thinking, why? Every day the weather will be changes. So before we start, I would like to introduce myself. I'm Madihah Jafar Sidik. I'm a senior lecturer and also oceanographer in Borneo Marine Research Institute, Universiti Malaysia Sabah. I have 14 years experience in oceanography and meteorology studies. For adik-adik yang tak tahu what is meteorology, meteorology is a study about climate. Untuk yang study for weather, untuk cuaca, we call it as a meteorologist, but for climate, we call it, the person is a climatologist. Climate and meteorology. That's two things, berbeza. I will explain later on. I got my PhD in oceanography in Bangor University in United Kingdom, Wales. I'm very proud to share with you or to mention that I'm a homegrown graduate. I did my bachelor degree and my master in marine science in Universiti Malaysia Sabah, and I'm very proud to serve UMS. Hopefully until I retire. Okay, so here, before we start, I would like to share a quote, from famous oceanographer, Matthew F. Maury, 1855. He said that our Earth, our planet is invested with two great oceans. Okay, one visible, which is ocean. We can see ocean. Ocean contain water, and another one is invisible. We can't see it. Atmosphere, air. One over foot di bawah kaki kita, sea level, and the other one overhead, di atas kepala. Okay, one entire envelope and the other one is 2/3 of its surface. Means that yang invisible ocean, dia menyeluruhi, meliputi seluruh bumi kita, and another one is 1/3, 70%. Okay, so this is what we are going to I would like to share with you, yeah, what is ocean and what is atmosphere. Okay, this is my list of content. I will talk about ocean, what is ocean, and I will talk about atmosphere, the sun and the earth, ocean circulation, global atmospheric circulation, and then how these two things, ocean and atmosphere or air, will will govern, the weather patterns and climate, and after that, extreme weather event. Okay, first of all, let's go to ocean. Yeah, what is ocean? Our ocean. Yeah, you can see ocean everywhere. Yeah, if you in KK or in Sabah, for example, in Kota Kinabalu, we can see ocean quite near to us. Yeah, so ocean is we can see everywhere. Yeah, it contains our earth is contain about 70% of water and 30% of land. Ya, maksudnya lebih banyak air laut di bumi kita compare dengan land. Yeah, that's why we need to concern, we need to kita kena jaga laut kita. Sebab bumi kita ni lebih banyak air, lebih banyak ocean. Yeah, that's why study of ocean is very important. Yeah, okay. So the total of Earth, yang 70%, if our Earth covered by ocean or by water, 97% is saline water, air masin. Yes, saline water means air masin. Only 3% fresh water. Yeah, air tulin lah, air fresh water. Okay, so fresh water ni maybe you already know that it's come from lake, yeah, from swamp, from river, from rain. Yeah, if you in KK now we are having heavy rain. Yeah, sekarang ni. So it's a source of our fresh water. Okay, I think you're already you quite clear about this. And then the next. Okay, next is what is salinity? Yeah, means that, as I mentioned to you just now, that 90% of our water consists of saline water, salt water. Okay, so means that the composition of our ocean water, 96.5% is H2O, air. Yeah, air tulin lah, yeah, air biasa. And the small portion, 4.5% will be salt, garam. Dia inilah composition of ocean. If you can see here, dia ada chloride, dia ada sodium, magnesium, sulfur, calcium, and others. Yeah, so only small portion of the salt boleh buat air kita jadi masin. So usually in oceanography study, kita we measure kadar kemasinan air laut itu with parameter that we call salinity. Yeah, so what is salinity? Salinity is a saltiness or amount of salt dissolved in a body of water we call saline water. So adik-adik, next time you already know that how to measure tahap kemasinan. Yeah, if you can see here, fresh water from river towards the sea, dia punya kadar ratio, the gradient of salinity will be changes. Yeah, so it means that why we need to know about the salinity. Sebab as mentioned before from the previous speaker, my friends, Dr. Audrey, Dr. Faihana, mengenai ikan, so means that we need to jika kamu suka sesuatu jenis ikan, dia ada adaptation. Ya, dia tidak semua boleh hidup di kawasan yang sama. It's depend on salinity. Ya, river from zero, from brackish, kalau dia punya PPT, tahap kemasinan dia kosong or less than 0.5, we call it fresh water, or kalau dia more on 0.5 to 70, brackish water. Okay, so average lah, biasanya yang biasa kita boleh dapat kadar kemasinan air laut adalah 35, part per thousand. Okay. So, world ocean. How many ocean in the world? Kan? I already mentioned here, I think you already know that. Yeah, there are 5 ocean in the world. Yeah, we have Pacific Ocean, Atlantic Ocean, Indian Ocean, Southern Ocean and Arctic Ocean. Yeah, Antarctica Ocean, sometimes they call it as a Southern Ocean. Yeah, so this is the location of these 5 oceans in the world. Yeah, if you see the map. Yeah, kita ada. So here is Malaysia. You can see here Malaysia. Yeah, we have in the west kita ada Pacific Ocean, and then we also quite close with Indian Ocean. Yeah, if you still remember ada tragedy kapal, dia apa ni, one of our plan kan dekat Indian Ocean. So that's why ni lah ocean yang quite near to Malaysia. Okay, so ocean and sea, ya, kalau dalam bahasa Melayu biasanya kita tak bezakan dua benda ni, ya, ocean and sea. Sebab kita panggil laut kan, dalam bahasa we call it as a laut, ya, antara laut dan laut, ya. But in English or in oceanography, ocean and sea are a different things, ya. Biasanya ocean biasanya there's a no boundary, ya. We cannot say oh this is Ocean Pacific and this is Ocean Atlantic. No, yeah, it's no boundary. It's very difficult to see the boundary. Yeah, dia tak ada nampak garisan. Yeah, it's like your house. You have a gate, kan? Ada kawasan. Yeah, but for ocean, no boundary. And however, for sea, a sea is a smaller and partially enclosed by land. Yeah, as you yang dekat dengan kita is South China Sea ataupun Sulu Sea. Yeah, dia adalah very close with the land. Yeah, enclosed by land. So this is the two different things lah. Kadang-kadang kamu tengok laut. Yeah, so that's why in bahasa, in English, sometimes you have inilah ada sedikit kekeliruan kan. Tapi if you study in marine science, yeah, ocean and sea are the two different things. Okay, so this is a world map of continent and sea. So you can see here kita ada Indian Ocean, ya, and apa ni dekat-dekat land ni kita ada nampak Andaman Sea, Java Sea, ya, Celebes Sea, South China Sea. Ni quite famous lah. If you go to Peninsula Malaysia, you need to cross, yeah, from Sabah to Peninsula to Kuala Lumpur, you need to cross the sea. So biasanya bila kamu nampak dari bawah plan tu, you can see the South China Sea. And you can see kan boleh nampak dia punya perbezaan warna from your eyes kan, boleh nampak perbezaan warna dia. Kenapa dia berbeza warna? Okay. Kenapa laut? Sometimes you can see a different color between area kan. Sometimes you can see like a turquoise and sometimes a bluish and dark blue. Okay. So you can see here, this is the map. Another words lagi untuk adik-adik yang di sekolah, we call it as bathymetry. Yeah, the first word you learn today is salinity. Kedua is bathymetry. What is bathymetry? Okay, bathymetry is referred as to the ocean depth relative to sea level. Ya, dia punya inilah bathymetry, kedalaman. So if you can see here, map dekat bawah ni, the dark blue refer dia punya depth inilah very depth. Ya, yang ini ni kurang lah, shallow area. Ya, so you can see here blue, kan, light blue and dark blue. Ya, so you can see dia punya depth. Ya, so kalau in geography we call it as topography. Ya, kalau you study in apa ni geography lah, nak tengok map, ya, kamu kena buat kontur kan, kontur map. But in oceanography we not call it as a topography, we call it bathymetry. Ya, so boleh nampak kedalaman air laut tu lah. So you can see here. So you might ask me, why we need to know this thing? Is it important? Yes, yeah, I can say that that's very important to know the depth. Yeah, for example, if you want to dive, you need to know how deeper you can go, kan? And then if you are fisherman or if you are a kapal container, yeah, how when you can which route that you supaya your your boat or your vessel tidak tersangkut. Ya, daripada kadang-kadang dia ada karang ke apa, ya. So you need to check bathymetry. Okay, so after this kalau ada soalan boleh tanyalah. Okay, and the next slide will be depth of ocean. Yeah, you can see how deep ocean. Yeah, so ocean is don't have it. It doesn't have constant depth. Ya, dia berubah-ubah. That's why lah dia punya perubahan tu we can plot or we can map using bathymetry. So here biasanya C dia ada lesser depth. Ya, C ni cetek lah compare relatively lesser depth compared to ocean. Yeah, and then smaller area, and also ocean lebih besar sebab dia tak ada boundary. Okay, so biasanya in sea dia more marine life compared to ocean. Now you may ask me why? Ya, sebab dia dalam sains ya, if you learn a science, you need to ask yourself why. Why you need to know why? Ya, sebab you cannot hafal mati lah. You cannot read and then keep like a fact ataupun macam apa-apa fact lah kan. Yes, you need to know the logic behind the information or behind the fact. So biasanya di kawasan sea dia lebih banyak marine life. This is because of light penetration. Ya, cahaya air laut dia boleh menembusi air di kedalaman yang cetek. Kenapa dia banyak haiwan marine life? Because of photosynthesis. Kan kita belajar dalam sains semua tumbuhan diperlukan photosynthesis. Yeah, so photosynthesis, so that's why like a plankton, so fish eat plankton, yeah. So banyak hidupan yang we can see under 200 meters. Ya, biasanya sea ni dia tak dalam sangat lah. So in the ocean there is a less marine life sebab dia very depth. Yeah, we call it as a midnight or ophatic zone. Yeah, which is light does not penetrate at all, very dark. So that's why you can see darker lah ya di kawasan like Pacific Ocean, yeah, and Atlantic Ocean. Yeah. So this is, you can see the layer, yeah, continental shelf, yeah, we have abyssal zone. Okay, so we call it this slope, yeah, from the continental shelf to huddle zone, we call it as oceanic zone. Yeah, yang this one ni macam lebih we can classify as a sea lah. Okay, so yeah, that's all about ocean. So let's go to the invisible ocean, yeah, atmosphere. So what you know about atmosphere? Yeah, A, yeah, commonly known as A, yeah, nama glamour dia atmosphere lah, but it content of A, yeah, udara dalam bahasa Melayunya. Is it why atmosphere is important? Yeah, it is very important because it helps us to absorb, yeah, ultraviolet, solar radiation, yeah, warming the surface through heat retention or green effect. Yeah, so it will reduce, yeah, temperature extreme. Yeah, cahaya matahari itu sangat panas. So we need, yeah, atmosphere untuk dia protect us, yeah, untuk meliputi earth. Ya, dia cover like very invisible, lut sinar. Ya, but it is very powerful. Ya, walaupun dia lut sinar, dia sangat powerful sebab it can absorb inilah ultraviolet, which is very dangerous to our skin. Ya, kadang-kadang boleh dapat inilah masalah kulit, ya, sunburn and others lah. Okay. So what is content, composition of atmosphere? As just now I mentioned to you, ocean dia content dia H2O dengan garam, salt. Ya, tapi H2O dia banyak, salt dia very little, less than 5%. Yeah, what about atmosphere? Yeah, atmosphere is a air, it contain mixture of gases. Ya, ada banyak-banyak gas. Ya. The majority gas is the dominant gas is nitrogen. Okay, 78% of our air contain nitrogen, and after that followed by 21% of oxygen, and yeah, only 1% carbon CO2, carbon dioxide. Okay, so we also have water vapor here. Yeah, less than 1% lah water vapor in our air. Okay, walaupun water vapor ni sikit, yeah, very small content inside the air, tapi dia memainkan, it play a very big role in determining the climate, ya, ataupun udara lah, dia punya tekanan semua. Okay, alright. If you want to know more about that, yeah, you can choose marine science, and we can learn more about this subject, yeah, about atmosphere. We have one subject that I teach you about the atmosphere. So I just can share a little during my talk, yeah, only 40 minutes talk. That it's not enough for me to talk about atmosphere. Okay. So atmospheric layer, okay, macam juga ocean tadi kita ada layer photic zone, aphotic zone, yeah, and also midnight ataupun yang gelap lah, dark. It's similar juga dengan our invisible ocean overhead, yeah. We have 5 layers. Troposphere, di mana kapal terbang, ya, if you go take your passenger plane, ya, passenger plane will go until from ground to troposphere. Okay, and after that followed by stratosphere, yeah, it's around 11 to 50 kilometer from the ground. Ya, biasanya radiosonde, ya, radiosonde ni every day Jabatan Meteorologi, Jabatan Iklim, kaji cuaca, ya, dia akan lepaskan radiosonde ni untuk measure vertical punya condition of air, ya, dia akan naikkan. So this radiosonde will measure from ground to stratosphere layer of atmosphere. Why we need to measure atmosphere? Is it important? Yes, it is. Yeah, for weather system, untuk plan, okay? And after that, followed by mesosphere, which is if you can see meteor, ni lah, yeah, tahi bintang, meteors means that meteor will cross to mesosphere, okay? So if you happen to see aurora, ya, aurora biasanya dia di kawasan thermosphere. So you can see, oh, that's aurora. Oh, okay. Now I know it's indicate that the layer will be is a thermosphere of atmosphere punya layer. Okay, spaceship and satellite. Okay, macam sekarang you can see me online, yeah, from here, from Kota Kinabalu. Maybe you are in other places. So how we can communicate visually because of the satellite, yeah, the signal, like a mobile phone. So the mobile phone, your mobile phone will send the signal to extrosphere, and after that get back to you. So means that you can't see the invisible wavelength. Okay, so means that we inilah kita sistem atmosphere. Okay, begitu juga there's no boundary between atmosphere and outer space, ya. Ya, tapi dia punya konten adalah A, ya, mixture of gases. Alright. Okay. Now the third topic. So you already know about ocean, you already know about atmosphere, the content. So let's go to relationship between the sun and the earth. Okay, the earth receives most of its energy from the sun radiation. Ya, kalau without cahaya matahari, ya, kita akan mati. You know why? Because kitaran lautan berpandukan ataupun it's dia generate by the sun radiation. Okay, and then the sun warms the planet and then drive the hydrologic cycle and makes life on earth possible. Yeah, without hydrologic cycle, I think you already know what is hydrologic cycle. Macam hujan, dia turun pergi laut, and after that kita ada proses sejatan, ya, evaporation, and after that cloud formation, condensation, and this is the kitaran. Yeah, so without sun light, this kitaran, this cycle, it's impossible. Ya, dia tidak akan bergerak. So without water, without kitaran, life on earth will be impossible. That's why I said, yeah, the earth, yeah, the sun is very important for earth to survive. Yeah, so the sun is the primary source of energy for Earth climate system. Yeah, without the sun, we don't have we can't experience hujan, panas. Ya, without sun juga bumi ni akan beku, akan sejuk. Ya, sebab tidak ada bahan pemanas untuk dia berfungsi. Yeah, so you can see cahaya matahari, it will penetrate to the earth, and after that it will inilah buat hydrologic cycle. Okay, so you can see here. Right. So before we go further, I would like to back to basic of physics. Yeah, if you remember about state matter, we have solid, liquid, and gas. I would like to refresh ataupun ingatkan kamu baliklah back to basic. Before we go to the circulation, I would like to recall balik dia punya basic physics. Okay, if you remember that solid, dia punya struktur molecule or zarah-zarah inside this matter, bahan-bahan ini, dia punya kinetic energy adalah dia punya molekul adalah dekat. So if you hit that one, dia punya kinetic energy will be low. If you hit the gas, it will be very active. High kinetic energy. Solid dia mempunyai low kinetic energy, gas mempunyai high kinetic energy. Okay, kenapa? Sebab ruang-ruang gas dia ada space. It can move freely. Macam kamulah, kalau kamu dalam kereta yang kecil, bila kamu susah nak bergerak. But if you dalam lori ke dalam bus, you can stretch. Inilah boleh deparkan tangan semua. So bila panas, you can move around. Begitu juga dia punya sifat-sifat molecule. So this one is gas. Bila when we put the energy, bila ada matahari ataupun heat, dia akan berubah from liquid to gas, from gas to solid. From solid to liquid. Means that because of the sun light, solar insolation, udara ataupun wap air dia boleh berubah. Okay, yang berubah tu adalah wap air, bukan gas tu yang berubah, bukan nitrogen, wap air, water vapor, and also convection. If you hit the A, A yang panas, dia akan intend to bergerak ke atas. Why dia bergerak ke atas? Sebab dia banyak kinetic energy. That's why I would like to recall balik back to basic physics. And this is very basic for physics. Before I explain more about the ocean circulation. Sebab apa? When the sun hit the ocean akan jadi panas. So bila dia akan jadi panas, what happen? Dia akan bergerak. It will move. Circulate. Dia tidak bergerak, dia tidak diam saja. Dia akan bergerak. So bila dia bergerak, it will push the cool water pergi bawah. Alright, so let's go. The next slide. Pasal ocean circulation. Okay, not yet. Satu lagi. So you can see here, bila bumi kita bukan tegak, bumi kita bulat, bukan rata. Okay, that's the very important fact. Bila bumi kita tilt, in bahasa we call it bengkok, condong. Sorry, not bengkok, condong. Condong. It's not straight. It's 22.1, 22.5. Sorry, half. So dia tilt. Bila dia tilt, and then dia juga rotate. Our ocean is rotate. Bila dia rotate and tilt, cahaya yang dia punya intensity, dia punya kadar kepanasan yang maksimum will receive it dekat tengah. So you can see here equator. Equator will receive more intense heat compare di kawasan polar. You can see here. Dia lebih panas. So maksudnya when you hit the A, okay, the invisible earth, invisible ocean, it will move. Bergerak, kinetic energy, we inject the heat into the water, into the air. So maksudnya bila we inject the heat, dia akan bergerak, aktif. Okay, so thus heat in the earth transfer by ocean and atmospheric circulation. Bila kita panaskan, so that's why in equator, that's why you don't complain say why we don't have snow here. Sebab bumi kita adalah condong 22.5. That's why we receive. We need to be grateful. Need to be blessed because kita lebih banyak dapat cahaya. We can do a lot. We able to do inilah. Kawasan kita banyak photosynthesis. Very rich of a biodiversity. We need to be blessed. Okay, don't complain. Okay, so by distributing heat over the globe, ocean current have a major impact on global climate. So bila pergerakan ni kan, bila dipanaskan, dia akan bergerak. Dia tak duduk. Why dia bergerak? Sebab dia ada we inject we trigger the kinetic energy inside the liquid ataupun ocean ataupun the atmosphere. Okay. So ocean circulation. Alright, ocean circulation. So ada dua jenis, as we know that equator will receive, equator receive banyak heat kan, very high intensity of heat, so it will move to higher area, Okay, so in ocean circulation, there are two types of ocean current, When we talk about ocean current, maksudnya movement lah, dia kalau you direct translate in bahasa current, ini ombak, arus, dia ada ni lah. So that's why I like to share my notes in English supaya dia tidak misleading. Sometimes bila you translate some terms in oceanography, it will be misleading. So dia ada pergerakan current. Satu adalah surface current, horizontal, di kawasan photic. Yang another one is deep water, vertical. Dia horizontal, dia bergerak, and juga dia ada pergerakan vertical. Yang horizontal mainly driven by the wind. So bila kamu nampak dia kamu nampak perbezaan bila nampak ada rasa angin, so maksudnya angin juga akan driven, akan memacu pergerakan air laut. Pernah kamu nampak air laut tidak bergerak? Diam saja, very tenang saja, di lake okay, ataupun di kolam. Even though if you have a ball, kamu tiup saja sikit, dia akan bergerak. Dia akan dia ada current, ada movement. So it will not stop. When you stop blowing, dia tak akan terus stop. It will take times. We call it as a resonance. That's one is another physics things that if you love to study more about this detail, I will in marine science we will learn this topic in physical oceanography in first year. Okay, so for in general, you just for the time being just ni je tahu dua ni sajalah, dia surface current, horizontal, and also deep ocean current. Deep ocean ni dia memang tidak pergerakan dia bukanlah dijana oleh angin, tapi dia dijana oleh density. As you know that I mentioned earlier, air laut kita ni dia consists of salt. Jadi dia ada different salinity. Bila dia different salinity, dia akan yang berat dan yang sejuk akan tenggelam, dense. Yang fresh water ataupun kurang salinity dia akan ke atas. Bila dia disejukkan, dia akan dense. Why it dense? And again, it's related to kinetic energy. Bila dia sejuk ni, kinetic energy dia kurang. So bila dia kurang, dia tidak bergerak. Alright. So ocean surface, so you can see ocean water move in predictable way along the ocean surface. kita boleh predict dia. Ya, kenapa? Sebab dia inilah dia ada because of continental kan, kawasan tanah. So bila dia bergerak, dia akan ikutlah. So you can see here around kan. For example, from west wind drift kan, dia naik atas. So you need to remember this the dash ni referred to equator. Bila ada equator, we receive high intensity of light, ya, atau high intensity of excuse me, high intensity of sunlight. Jadi bila dia ada high intensity, kinetic energy pun ada banyak, dia boleh move pergi kawasan sejuk. Bila dia push air, ombak ataupun water pergi bawah lah yang so you can see here the blue one will be the cold water, the red one it's derived from the equator sebab equator panas. Yeah, so you might ask me why, if you notice that in northern hemisphere dia punya kitaran is counter clockwise, ya, arah lawan jam. Ya, kalau sorry, yang ini ni ikut yang di equator, di northern hemisphere dia arah dia clockwise, ikut jam. Ya, dia punya pergerakan, ya, we call it kalau di southern hemisphere dia lawan arah jam. You might ask me why. Ya, the reason behind it because of Coriolis force. Ya, if you kalau saya explain it will take 2-3 days lah. Actually for one lecture lah. Okay. So I just leave it for that. That's why they are different lah. Dia punya rotation. Yeah, because of earth rotation. Okay. So surface current can flow for thousands of kilometer and reach depth of 100 of meter. Ya, surface water ni, ya, kan dia ada dua jenis, satu horizontal, satu vertical. Ya, walaupun dia surface water tapi dia boleh bawa air tu sehingga 100 of meters. Ya, this is because of Ekman transport. And again, lagi satu fizik, ya, ocean punya sebab. If you want to know more, you need to enroll in marine science. Okay, tapi in general you need to know we can predict the movement of ocean water and also it can flow thousands of kilometers. That's all, for the time being. Okay, so you can see here, kan saya ada mention tadi in northern hemisphere dia ikut clockwise and another in southern hemisphere dia akan ikut arah lawan jam. Lagi satu, next time if you travel to northern hemisphere, like example Australia, cuba buka paip, you tengok dia punya di sinki, tengok dia punya kitaran air. Dia akan counterclockwise. If you happen to go abroad, for example in UK ataupun in Malaysia dia kurang sikit lah sebab kita kawasan equator, which is Coriolis force dia tak berapa kuat. If you go to subtropic, bila you buka paip, paip ni dekat sink, boleh nampak dia akan ikut clockwise. This is due to Coriolis force. I want to explain what is Coriolis force for this time. Maybe in another talk or maybe in my lecture. If you happen to enroll in marine science. But this is only the general lah yang saya boleh share. Okay, so walaupun this current won't stop, walaupun ada storm, walaupun ada typhoon, it keep on continuing bergerak. Surface current are created by three things. Kenapa dia boleh bergerak walaupun ada typhoon sekalipun? It won't stop. Because of global wind pattern. Global wind pattern. Dia akan sentiasa sebab bumi itu dia takkan berubah dia punya kedudukan. Dia condong 22.5 lah. That's why it will receive, equator will receive heat yang paling intense. So that's why it will flow. So weather which is a very regional, it's not affect the whole area. So that's why it won't stop this circulation. This very main circulation. Okay, so how this three thing yang saya cakap tadi itulah Coriolis force. Okay, right. So this is about surface current. So deep ocean current, ya, yang vertical. Tadi kita cerita pasal horizontal, ini kita cerita pasal deep ocean circulation. Dia inilah. Okay, deep ocean circulation is primarily driven by density differences. Ya, macam tadi dia from surface to several meter kan, 100 meters kan, like 200 meters, it's still influenced by the ocean, inilah surface ocean. But for deep ocean circulation, dia disebabkan density. Ya, air garam dengan air tulen, air garam akan sink. Ya, air yang lebih masin dia akan sink. So bila dia sink, it will create the movement. Ya, dia ada movement, dia ada current over there. Yeah, we call it as this movement, the vertical one, we call it as a thermohaline circulation or ocean conveyor belt. Ya, macam kalau kamu pergi airport ataupun makan sushi king, dia ada conveyor kan. Ya, so you put your wasabi jalan, begitulah dia bergerak. Ya, dia ada belt dia. Ya, so this one it's if you see the figure here, yang merah ini adalah warm surface current, ya, which is generate di mana? Equator. Sebab apa? Equator dapat banyak heat kan, intensity from the sunlight. So bila dia bergerak, bila dia bergerak, dia akan hilang heat dia from inilah macam kamu bawa kopi panas, kamu pergi pagi-pagi, kamu bergerak, mungkin you can have a walk with your cup of coffee, and after that, after 30 minutes, you can see that dia tidak sudah 100 degree, dia hilang sudah heat dia kan, because of inilah heat dia hilang. So maksudnya bila dia hilang, dia akan kinetic energy will be inilah kurang, ya, dia bukan kurang, tenaga dia tidak pandai habis, ya, maksudnya dia di transfer, energy transfer, so dia kurang kinetic energy, it will sink. So you can see here, ya, daripada red dia akan pergi blue, yang blue ni pun dia akan bergerak, and then dalam satu tahap bila dia bergerak, bila dia pergi ke kawasan equator di mana kawasan surrounding agak panas, relatively dia akan naik balik. Yeah, so we call it as a conveyor belt. Yeah, density differences, yeah, due to temperature and salinity. So apakah faktor yang membuatkan arus ini bergerak? Disebabkan oleh temperature. Dia akan influence by surrounding temperature and also surrounding salinity. Okay, yeah. So inilah dia punya pergerakan. Ya, thermohaline circulation. Ya, density difference. Okay, density difference are small and flow velocity is low. Ya, different salinity dia. Sebab kalau kita tengok tadi salinity, ya, tahap kemasinan tu for ocean is only 35. Ya, but the different walaupun dia different dia rendah ataupun kecil, ya, the water mass moving around the thermohaline circulation are huge. Ya, it's covered, inilah banyak ini arus yang besar, ya, banyak. So bila mass of water tu banyak, so dia akan inilah kinetic energy. There's physics theory lah behind it, ya, if you go. Tapi to make it simplify, dia bergerak disebabkan perubahan salinity dan juga perubahan temperature. That's why it will sink ataupun it will goes up. We call it as a upwelling. Yeah, this one is downwelling. Tapi upwelling and downwelling, it's not only for thermohaline circulation. Dia ada lagi lah. Yeah, if you want to know more, and again, I would like to promote to I can inilah. If you want to know more, please enroll Marine Science in Universiti Malaysia Sabah. Okay, so you can see here. Yeah, kalau kamu pernah tengok cerita Nemo kan, di dalam air laut tu dia ada satu jet stream, ya, arus yang kuat. Why ada arus yang kuat? This is because of different salinity lah. Yeah, so you can see here thermal line, yeah, warm, yeah. So here is equator. Ya, di sini ni southern hemisphere and this one northern hemisphere. So dia ada pergerakan, dia ada inside, ya, inside current inside the water, ya. So kalau kamu tengok Nemo, dia nak balik pergi Australia kan, dia punya kawasan. So it will follow inilah Arctic yang cold, dia ada jet stream dia. Dia follow that what it will inilah. So filem Nemo kalau kamu nampak itu adalah salah satu contoh one of the ocean conveyor belt. Ya, sebab dia dipacu oleh perbezaan salinity dan juga temperature. Okay. So atmospheric circulation. Okay, atmospheric circulation itu tadi pergerakan air laut. Ini pergerakan atmosphere pula. Ya, atmosphere macam juga tadi, it's quite similar with ocean disebabkan equator panas, so dia akan bergerak. Ya, cuma bezanya for atmospheric there's no land. Ya, kalau macam ocean tadi it will create a gyres, kan dia nampak bulatan besar kan movement. Kalau kamu tengok yang ocean current, surface current, kan surface current sebab dia cannot go cross inilah sebab ada boundary land, ada continents, it will inilah bend, dia akan deflect. Yeah, that's why dia membentuk bulat lah. Okay, untuk A pula we call it as a global atmospheric circulation. Yeah, so in equator to subtropics, yeah, bila dipanas, kan seperti mana yang tadi, back to basic, if you hit the air, it will increase the kinetic energy. Bila dia ada kinetic energy, it will rise up. What happen? It will rise up. Yang sejuk, udara yang sejuk akan replace pergi equator. And then that's why lah we can see cloud formation. Ya, salah satu lagi contoh ya, if you do a remote sensing study, that's why lah di kawasan equator sangat susah nak buat remote sensing study because of cloud formation. Bila ada cloud formation, we need to inilah dia ada noise, ya, dia ada halangan. Okay, sebab banyak inilah cloud formation di kawasan equator. Ya, atmosphere ini it's very easy to understand. It's also similar like ocean circulation because sun hit the earth. Yeah, and then also because of spinning. Yeah, I would like to, so you can see here. Nampak kan? Bila equator dipanaskan, udara akan naik. So you can see, yeah, this video. Okay, begitulah dia punya keadaan. Right. So here boleh nampak juga equator dia akan tolak udara di kawasan subtropical yang sejuk pergi equator. Dia akan inilah berpusing. So means that kawasan kita tidaklah terlalu panas. Ya, sometimes you say, oh kita terlampau dapat banyak matahari solar insolation, but this heat will be transport to other places, and the cold water or the cold air will be transferred to replace the heat yang sudah move tadilah. So dia ada Hadley cell, Ferrel cell. Yeah, it's referring to global atmospheric circulation. Okay, begitu juga ni dia punya pergerakan. Yeah, so in meteorology, convection refers to atmospheric motion in vertical. Yeah, in vertical. So okay, bila ada gradient macam ocean, dia ada horizontal and ada vertical juga. Kalau atmospheric circulation, dia pun ada vertical, dia ada horizontal. Horizontal ni bila kamu rasa ada angin, tiba-tiba duduk di beach kan ada angin. Maksudnya itu adalah pergerakan when the pressure gradient, from low pressure to high pressure, bila dia ada perbezaan pressure, dia akan bergerak ya, from high to low. So you can see, you can feel dia punya angin. Okay, and again sun merupakan dia punya primary source lah untuk pergerakan semua ni. Pergerakan udara dan juga pergerakan air laut. Okay, so you can see here air circulation kan? Oh sorry. Hot, cold air, sink, and then it will replace. And it also generate hydrologic cycle. Ya, bila udara panas dia akan naik. Bila dia naik dia akan disejukkan. Kan bila udara panas naik, hilang dia punya tenaga, it's not hilang lah. It will go somewhere ya, dia transfer to other place, and it will condensation ada cloud. And bila cloud tu dah berat, it will turun jadi hujan. So it's like a hydrologic cycle. Okay, now second last part. So bila kamu fikir balik if you reflect balik, pergerakan udara ataupun atmospheric circulation and also ocean circulation, this factor, dua benda ni lah yang create kita punya climate. You may ask me what is beza climate and weather. Weather, kalau you study about weather ni dia berubah. It's very changeable. Kenapa dia tidak stabil? Sebab weather dia punya parameter, one of the parameter is air. Kan kamu tahu dalam fizik kita tahu sifat udara ni macam mana. It's unstable. It can change anytime. Kalau ada heat, tak ada heat, changeable. So we call it as a weather pattern. Macam hari ni hujan, besok panas. That one is weather. For climate adalah pattern. For example, in Northern Hemisphere, bila akan ada snow ataupun bila musim sejuk. Every year, pattern. It is a long-term study. So meteorology, we call it as a meteorologist, belajar pasal weather. Kalau climate ni dia deal with the climate pattern yang memang huge lah. That person must be very good in statistics, climatologist. But they work together very closely. Okay, so disebabkan pergerakan air laut and also global air, kan, it will create the pattern of climate. So that's why in equator kita boleh nampak dia cuaca dia inilah summer wet, winter dry. Inilah abundant precipitation in all season in equator. ITCZ sebab dia dekat tengah dekat equator line, it will ada diverge kan, sebab dia panas dia akan rise up. So northern hemisphere will deflect to the right, and in southern hemisphere it will deflect to the left. Kenapa berubah? Because of earth rotation, which is we call it as a Coriolis force. Disebabkan Coriolis force itulah dia berubah. So kalau kamu tengok cuaca ni lah, in equator biasanya dia akan warm, humid, and air rises. Air rises. Udara akan naik. If you still remember the Hadley cell, and then it's cool and a lot of rain. Kita mengalami banyak hujan, because of precipitation. Because of evaporation. And then di kawasan yang 30 degree, so you can see here, kan, bila cold air sink, usually it will experience dry air sink to the surface. Dry. Sebab bila warm ni, bila yang merah ni, bila dia warm, dia akan bawa air. Walaupun dia panas, tapi dia akan evaporate water. It will bring water. So di kawasan 30 dia akan dry. Biasanya dia akan inilah kawasan gurun, which is near this latitude. In 60 latitude, it will be warm air from lower latitude. Akan ada angin sejuk lah. Di kawasan sini winter, wet winter, dry winter. So di kawasan ni, di mana sejuk, very relatively sejuk, tapi dia very cold air to the surface. Dia very dry sebab tak ada evaporation process. It's not tak ada, bukan tak ada langsung ya, dia kurang. Dia punya rate tu kurang. So that's why lah bila kamu pergi kawasan yang sejuk kan, sometimes you feel like dry, itchy, ya, kamu punya kulit kering sebab dia punya atmosphere ataupun dia punya air, udara dia kurang water vapor. Sebab apa kurang water vapor? Kurang rate of evaporation. Okay. Next slide. Okay, what is monsoon? Okay. Monsoon ni kita selalulah ya. I would like to highlight on my presentation about monsoon. Ya, monsoon ni about the seasonal change in a direction of prevailing or strongest wind. Ya, disebabkan perubahan angin. Angin lah. Ya, monsoon. When we talk sometimes, oh belum lagi musim monsoon. So when we talk about monsoon, we need to relate with the arah angin. Yeah, we call it as a summer cycle, which is we consider as a wet monsoon season, or winter cycle, dry monsoon season, kawasan yang kering. Yeah. Saya kena cepatkan presentation to allow for Q&A. So in Malaysia, we have only 2 monsoon. Yeah. So boleh tengok sini, yeah, kawasan southwest May to September. Sekarang kita Julai. So means that we are here lah. So our wind berasal dari Australia, yeah, from the land, high pressure. Why it's high pressure? Because dia rise up lah. Nah, ini juga monsoon ni disebabkan oleh equator ITCZ punya line. Ya, it's too detail lah kalau saya share di sini. Ya, so for northern monsoon, yes, dia lebih kepada inilah October to March, which is more rainfall. Maksudnya dia banyak udara yang datang ke tempat kita tu banyak water vapor. That's why it create more rainfall and it originate from China and not Pacific. Ya, daripada laut. Ya, dia angin dia macam ni. Ya, daripada laut. When we talk about laut, it will evaporate more water vapor. Okay. Ya, March and October biasanya dia transition lah. It's try to change the direction and sometimes you can experience typhoon or ya, inilah ya. Alright. Okay, and so yeah, sometimes a climate pattern also change with them. Sometimes it pernah dengarkan El Nino and La Nina, ya. And so it's about the temperature of water. Ya, dia perbezaan temperature di kawasan air laut yang menyebabkan pembentukan awan tu berbeza. Ya, kalau saya bagi simplify lah ya, I'm afraid that we don't have much time to explain more. Ya, for El Nino biasanya inilah why we concern about El Nino ni, sebab dia akan mengawal ataupun it will relate with kadar hujan yang kita terima di kawasan Malaysia ataupun South China, inilah Southeast Asia. Okay, and so dia ada 3 jenis, satu El Nino, La Nina and neutral. Ya, kalau biasanya kawasan kita ni akan equator kan, dia akan rise up and after that goes down and rise up macam ni. Ya, neutral. Tapi kalau time El Nino, dia cloud formation, ini biasanya cloud formation dekat ni lah, dekat kita kan, in our region. But during El Nino, dia dekat tengah. This wind, perbezaan angin ni, dia lemah. Ya, bila dia lemah maksudnya tak adalah awan di kawasan kita. Bila tak ada awan, kurang hujan. And it relate with the musim kemarau. Ya, and then kalau La Nina, dia very strong wind, tapi inilah akan banyak hujan di kawasan kita. So El Nino and La Nina. Okay, El Nino is relate with dry season, atau La Nina dia musim inilah wet season. Okay, so you can see here during El Nino and La Nina kita akan alami dry. Kalau El Nino kita akan inilah kurang hujan di kawasan kita. Tapi kawasan lain dia ada wet. Ya, sebab the circulation, if you still remember the Hadley cycle. Ya, kalau La Nina, our phase will be our area, our region will be wet and other area will experiencing dry. Okay, So the last topic I will go very quickly this one ya, because of this weather ni system ni, dia tidaklah macam cahaya matahari kan, dia mengelilingi bumi. Kadang-kadang kita ada cloud semua tu ya. Bila ada cloud formation ataupun ada apa ni, pusingan bumi kan, dia berpusing, bumi berpusing, so sometimes it will create the extreme weather event. Yeah, this is beberapa contoh lah yang event yang strong wind, yeah, tropical storm, tornado, blizzard, yeah. This is the example. I just go very quickly here. Yeah, this is how tropical storm form. Okay, if you want to know how they form, and again, I think you already know what I would say. General marine science. Okay, and then tropical storm, and then typhoon. Yeah, hurricane and or typhoon is a similar thing. Yeah, biasanya di US they use hurricane, but in Asia, yeah, di Asia dia orang guna typhoon ataupun tropical storm. Actually, these two thing similar. Yeah, tengoklah. Yeah, you can see here how the apa ni, atmospheric circulation, yeah, will create this extreme event. Yeah, there's a theory lah behind it. Yeah, I won't go very detailed during this time. Yeah, if you want to know, yeah. Okay, and then tornadoes. Yeah, ni disebabkan high cold water, and after that there's warm water. Yeah, bila ada warm air rise up meet by high cold air, it will create inilah turbulent. Yeah, that's why inilah will create inilah form tornado. Okay, so this is a blizzard. Yeah, it's a heavy snow for a long time. Inilah a long period. So kalau di kawasan kita, we can see rain, but when in cold air, it will inilah turun sebagai snow. Dia punya precipitation. Okay, hail. Yeah. So hail is a solid precipitation. Yeah, this is a photo of me during hail. So you can see it's like a hujan batu di negara orang, yeah. Okay, so this is one of example lah extreme weather event. Okay, flood. I think you already know, ni quite familiar, yeah, because of heavy rain, yeah. River, mungkin heavy rain kan disebabkan oleh monsoon and enhanced by the ENSO phenomena. Mungkin time La Nina, which is it will tambah lagi dia punya kadar hujan. Kenapa? Sebab dia punya hardly circulation kan very strong. So it will create more cloud, more air rises up, and it will create more cloud formation. Ya, this is Kota Belud tengok contoh. So hujan ni disebabkan inilah pergerakan udara dan pergerakan laut. Okay, so summary. This is my last slide. Okay, so sunlight, ocean circulation, global atmospheric circulation equal climate pattern. So this climate pattern ataupun extreme weather event disebabkan oleh inilah dia punya faktor sunlight, ocean circulation, and global atmospheric circulation. And what we experience now, it's a climate pattern. Yes, that's all for today. Thank you.
Thank you very much, Dr. Madihah. It was a very interesting and wonderful topic, and very well presented today as well as it relevance with the current meteorological and oceanic events. We invite Dr. Madihah to answer some questions by our today that were sent to us during the presentation. So our first question is from Syuhaida Isa. Fenomena ikan laut naik ke darat. Boleh saya tahu apa puncanya?
Okay. Terima kasih, saya Syahida. Okay, ikan laut naik ke darat, ya. Ikan laut tu biasanya bila angin kuat ataupun during storm surge, ya. It's biasanya yang ikan laut naik ke darat ni dia banyaklah faktornya disebabkan, ya. Another one is phenomena that I saw because of tornado ataupun belalai gajah, ya, kalau kita panggil dia not belalai gajah, belalai air, sorry, not belalai gajah, belalai air, ya, dia perubahan angin. Kadang-kadang dia boleh bila air pasang, dia boleh bawa air pasang diikuti dengan angin kencang, it will bring all the water to coastal area ataupun nearby lah. Ya, that's why dia boleh naik lah. Dia bukanlah ikan tu sendiri yang datang pergi, but some of fish can do that lah, like salmon and other fishes, but I'm not good in it's not my expertise doing this biological study. But in terms of physical phenomena of the ocean, we can relate with mungkin di kawasan itu during air pasang. Ya, bila ada inilah air pasang, dia boleh bawa ikan yang di kawasan coastal, diikuti juga dengan angin kencang, it will bring the water mass pergi bawa pergi ke pantai. Macam tu. It's depend, banyak lah dia punya sebab-sebabnya. So we need to know the situation, we need to investigate dululah. Is it during that time hujan ke? Kalau for example ada tsunami, earthquake ke, bila ada earthquake kan, air tu dia akan surut dulu sekejap. Itu pun we can see a fish. Yeah, so tengok fenomena, tengok situasi. We need to investigate first and then baru boleh tahulah bagi kesimpulan yang tepat. Itu jawapan saya. Any other question?
Alright. Thank you, Doctor. The next question is by Justin. Air membeku di dalam peti sejuk. Mengapakah air di dalam ocean tidak membeku walaupun di Antartika?
Okay. That's a good question. Ya, sebab dalam peti sejuk dia tidak ada pergerakan. Ya, we don't have atmospheric circulation. Ya, bila atmospheric bergerak, ya, bila udara tu bergerak, dia akan mengubah suhu di kawasan tersebut. Yang bermaksud suhu tu dia tidaklah membeku saja di situ kan, maksudnya. Jadi bila dia ada pergerakan atmosfer, ada pergerakan air laut, so maksudnya dia ada bergerak. Ya, bila ada bergerak, it will create a heat, a little bit heat. So dia tidak akan membeku. Ya, lagi satu, bila dia membeku glacier, garam akan dense. Ya, bila garam akan tidak turut membeku. Yeah, that's why it will create. If you still remember horizontal conveyor belt, kan bila garam di kawasan equator tu kawasan kutub tu tinggi, dia akan dense water, it will move. Kan perbezaan salinity dia akan membuatkan itulah yang menjana pergerakan ocean conveyor belt, or we call it as thermohaline circulation. That's why lah dia tidak membeku, ais tu tidak membeku sebab dia ada pergerakan. Ya. Yeah.
Alright, Doctor. The next question is, adakah ribut tropika atau typhoon juga disebabkan oleh convection daripada pemanasan atmosfera?
Yes. Yeah. Okay, biasanya kan, okay, I would like to share that kita Sabah, for example, ya, kita berada di 5 knot, ya, 5 degree knot of in northern hemisphere, in peninsula 2, ya. Kawasan-kawasan kita ni adalah dia when we call it as ITCZ, ya, kawasan intertropik, yang di kawasan di mana udara akan rising up, ya, dia akan kitalah menjana macam kita hidupkan api kan, masa air panas. Kita di kawasan yang inilah, di kawasan yang panas, dia akan create cuaca yang panas, it will create rising air. Bila rising air, biasanya yang akan dapat typhoon adalah di mana kawasan yang terletak di 10 north ataupun 10 south. Ya, that's why kadang-kadang Sabah kan dia terkena tempias-tempias typhoon sebab kita dekat dengan 10, ya, compared to peninsula Malaysia sebab dia 2 knot, ya. So udara tu disebabkan pergerakan, like if you still remember Hadley cycle that I explained you just now. So this will create the typhoon, ya, disebabkan pergerakan inilah typhoon akan terbentuk di beberapa kawasan disebabkan kadang-kadang dia from the land, ya. Udara tidak sama, ya, bila di kawasan air laut, dia rising up di kawasan air laut dan di kawasan land tidak sama, sebab bila pemanasan di kawasan land solid, tenaga dia lebih banyak compare dengan tenaga di air laut. Yeah, it's again we back to basic. It is all about the kinetic energy of the air in that region, specific region. Yeah, when we talk about weather, it's more on region. Yeah, we cannot simplify. Oh, sebab dia sama saja dia punya kadar. Tidak, sebab dia very unstable. Yeah, air is not very stable.
Alright, Doctor. For the next question is, adakah perubahan monsun mempengaruhi ocean circulation?
Sebenarnya terbalik perkataan sentence tu. Disebabkan dia bukannya cycle, ocean cycle, monsoon ni disebabkan oleh atmospheric circulation, ya. Yeah? It's not about the about the ocean circulation, ya. Yeah? Sebab atmospheric kita bergerak, and also bumi kan, bila bumi kita kan condong 22.5. And then dia akan, that's why if you still remember, ataupun kalau kamu notice, di kawasan Northern Hemisphere, Disember akan jadi winter. Sebab apa? Dia dia ada equinox dan dia ada ini kan, di mana waktu hujung tahun tu, ya, di bulan Disember, bumi di kawasan North Hemisphere akan jauh dia punya dia punya jarak dengan matahari. So bila dia jauh dengan pergerakan matahari, so dia punya air circulation pun dia akan relatively change, ya, compared to during December, June. Ya, sebab kita punya bumi ni kalau kita tengok dia bergerak mengelilingi matahari. Kadang-kadang bila June, North Hemisphere will receive more heat. Bila December, itulah during Christmas kan, December, Australia will receive very high intensity heat kan. So bila perubahan kedudukan position of this earth, it will affect the air circulation. Ya, yeah? So maksudnya bila air circulation ni berubah, arah angin pun turut berubah. Bila arah angin turut berubah, bila dia datangnya dari daratan, dia kurang water vapor. Dia kurang hujan. So it means that monsoon disebabkan oleh angin. Dia tidak but it will dibantulah support by the air circulation. Ocean circulation dia tidak berubah. Kan tadi biar ada monsoon ke apa, dia akan bergerak because of the Coriolis force, because of the density. Yeah, it's not related with the monsoon. Yeah.
Alright,
Any
Doctor.
other question?
Ada lagi beberapa question. The next question is, how to know the typhoon classified?
Sorry?
How to know a typhoon is classified as?
Dia punya classified, dia punya inilah. Okay. Kekuatan dia.
Ya, betul.
Okay. Okay, if you want to know the macam tadi as I mentioned just now, we have a scale, ya, skala. Ya, kalau macam gempa bumi, kita measure dia menggunakan skala Richter. Ya, kalau angin biasanya we call it as a Beaufort scale, ya, untuk Beaufort scale. Tapi kalau ada tornado, kadang-kadang hurricanes, they have their own scale. So kita kalau inilah, ya, kalau dalam belajar science, we need to buat observation, ya. We cannot see, angin kuat, ya, we cannot do prediction by our own, ya. So untuk tahu intensity of the typhoon or hurricanes or a tropical storm, we need to measure the wind velocity. Ya, dia punya velocity of the wind. So bila velocity dia banyak, maksudnya inilah ya intensity. And then bila kita tengok kan biasanya meteorology department kan dia akan tengok besar cloud. Kalau tengok daripada satellite kan biasanya kalau typhoon ni dia akan nampak dia punya cell kan dia punya mesoscale tu, they will measure ya using scientific modeling. Ya, itu dia.
Alright, doctor, for the next question is how a tsunami occurs.
Tsunami, okay. Yeah, tsunami, yeah, it's quite famous. Tsunami ni disebabkan, it's not related with the circulation lah. Yeah, it's about the earthquake, yeah, di kawasan inilah, in the ocean, yeah. Bila ada earthquake di kawasan ocean, di dalam ini kawasan, how we call it, I forgot already. Okay, bila di dasar laut, yes, di dasar laut bila ada macam contohnya lah, kalau dia di daratan dia tidak melibatkan mass of water. So bila dia di dalam dasar laut ada gempa bumi. So bila ada gempa bumi, sebenarnya gempa bumi di dasar laut ni sering berlaku, tetapi kekuatannya tidaklah kuat. Ya, dia tidak kuat ya. Jadi tapi bila kejadian di mana earthquake berlaku di dasar laut dengan kuat, dia akan mengubah ya, dia akan displacement of water. Ya, contohnya macam ni kan dasar laut. So bila dia ada displacement of tectonic, so bila dia ada pergerakan dasar laut, air akan turun. So dia ada tenaga, kan dia ada daya tujahan ya, daya tujahan dia tu. So bila dia terturun and then after that it will and again it's relate with the physics theory, dia akan bagi satu daya tujahan ke inilah. Dia ada inilah processes yang di mana macam mana air tu boleh menyebabkan tsunami will hit the coastal area. Ya, sometimes kalau kadang-kadang ada bila kamu dengar dia ada tsunami alam, tapi mungkin dia tidak ada tectonic displacement. So maksudnya dia ada tsunami, tetapi dia ada amaran tsunami, tapi dia tidak menyebabkan ada earthquake, tapi dia tidak menyebabkan tsunami. Tidak semua earthquake di dasar laut akan menyebabkan tsunami. We need to also check the epicenter. Adakah dia berdekatan dengan pantai ataupun tidak? Ya. Yeah?
Alright, doctor, the next question is boleh ke hujan ikan?
Sorry?
Boleh hujan ikan, ya.
Hujan ikan. Oh,
Ya.
okay. When I teach during my lecture pun my student ada inilah ask me about this thing ya. And again ni yang pasal hujan ikan ni adalah disebabkan perbezaan udara, the gradient ya of the air ya, disebabkan pressure. Jadi dia akan membentuk tornado ya, tornado atau we call it just now lah as belalai air ya. Bila dia ada tornado, dia akan sedut semua everything in the water, and then bila dah tenaga tu habis ya, ikan-ikan yang dia sedut tu dia akan jatuh lah kan, macam air hujan, tapi it is a fish actually ya. Itu disebabkan very rare event, we can say it's not a phenomena lah, it's an event ya, disebabkan pembentukan belalai air ataupun we call it as a tornado in the water. I think dekat Penang pernah sekali ada viral dia orang letak ada hujan ikan, if I'm not mistaken. Yeah. Any other question?
Okay, doktor, ini soalan terakhir. How sandstorms can happen?
Sandstorm?
Yeah.
Sand, okay. Oh ya, sandstorm happen biasanya di kawasan inilah gurun lah ya, desert kan, di kawasan desert. Ini disebabkan bila ada gradient Ya, kan kamu mesti ingat bila udara dipanaskan, dia akan rise up and then dia akan turun. Tapi bila di kawasan dua region yang dekat, Basal, yang mempunyai dua perbezaan udara yang sangat berbeza, so dia akan wind blowing akan kuat. Ya, bila wind blowing akan kuat. Macam inilah, kalau sometimes kan kita rasa kadang-kadang tidak ada angin, kadang-kadang ada angin. So bila ada angin kuat, maksudnya dia terbentuk dua pressure gradient yang tinggi. Yeah, that's why you can see, you can feel the angin. So bila ada gradient pressure di kawasan 2A masses, kan? So di kawasan desert, dia akan bawa sekali. Desert ni adalah is like aerosol, dia ringan. So dia mudah untuk dibawa mengikut angin. Ya, so dia akan membentuk. Dia sama juga seperti pembentukan tropical storm atau typhoon di kawasan inilah di kawasan kita. Kan disebabkan perbezaan udara tu, dia punya perbezaan panas, and it will create the different pressure, disebabkan juga air masses, ya. Dia ada, yeah, it's also relate with the convection actually. All this situation is disebabkan convection. Udara panas naik, udara turun. Tapi bila dia punya intensity udara ni laju, ya, tinggi, so you can feel, yeah, the circulation is very fast, yeah, dia akan nampak, the intensity akan tinggi disebabkan perubahan dua kawasan yang mempunyai dua suhu yang berbeza. Begitu.
All right, thank you, Doctor, for answering all the questions by our viewers. We hope you all enjoyed this amazing and interesting presentation by our wonderful speaker today. The link for the registration and e-certificate is now being shared for school students and UMS students. Please fill in your details and answer the simple feedback questionnaire. All students will receive e-certificate, and for UMS students, you guys will receive STP points. Okay, thank you again, Doctor, for answering those questions and for the amazing presentation. Thank you also to all students, audience today for your participation. We look forward to seeing you in the next STEM speaker series scheduled on 2nd August. It was a pleasure to have all of you with us. With this, we conclude the webinar. Thank you and see you again.